So there we go. Okay, so guys, what we did in quadratic model so far. First section, I gave you a quadratic model, like the one about mosquitoes or whatever. Here's the equation. And all the questions were masked in me asking you how to find the what? The vertex, or set it equal to 0 and solve a quadratic equation. Every single question fit one of those models. The second section was, I give you the data points. You had to use the TI-Nspire to do what? You had to find the equation, and then I ask you those same questions. What's the maximum? What's the minimum? Fancy ways of saying where's the vertex, okay? And then the third section was projectile motion. You had a very specific formula. H equal -1/2 gt squared plus initial velocity times x, or t, plus the initial height, okay? And then same thing, ask you questions about the vertex or when it hits the ground, solving quadratic equations. So we've got 2 more to do in this section for quadratic models. So 1 today and 1 tomorrow when I see you guys at the end of the day. And then when I see you on Thursday, we review. And then our assessment is on Friday. And remember, we have the weird schedule: 1, 2, 3, 6, 5, 4, 7. That's our new X. That's our X block. Every time we have an X day on Friday, you meet all classes. 1, 2, 3, 6, 5, 4, 7. I think is it. So anyway, that's it. Yeah, it is about uniforms. Yeah, yeah. So anyway, I have nothing to do with that. So this is like, you can shoot the messenger if you want, but that's it. So anyway, that's for you guys on the video too. So we've got that. So let's move on and talk about math now. So this section, it talks about quadratic modeling with borders. Okay, so what it means, borders, I mean like the mat around a picture frame, or you've got a walkway around a pool or something like that. So you've got some kind of square or rectangle, and you build a border around it. So these are the quadratic models we're dealing with today. So let's look at an example. You are sending out your family's Christmas card. This is from Awkward Family Photos. It's a site that I like to visit. So anyway, visit at your own risk. A 4 by 6 inch photograph is in a wooden frame of uniform width. The area of the frame's front is 39 square inches. How wide is the frame? Okay. So what is it we do not know? We need to define a variable. What is it we don't know? What would my variable be? Yeah. So let x equal the frame width. There's a clue right here. Let x represent the width of the frame. So that means that in this particular problem, that's going to be x, that's x, that's x, and that's x. I've got a frame of uniform width all the way around this lovely picture. Okay. Now, how do I find the area of the photograph? Yeah, it's going to be, this is a 4 by 6 photograph, right? So that's going to be 24 square inches. So that's the area of the photograph. What's the area of the frame? How about 39? Is that what it says in your book? 39 square inches? That's the area of the white area, the white frame or the mat area. Okay. How would I find the area of the photograph plus the area of the photograph plus the frame? Yeah, that's 24 plus 39 equal what? 63. So that's the total area of the picture and the frame all added together. Okay. Now, using the variable that we have here. So what I want to do is someone tell me, what is the distance from there to there using the variable that I have, okay? So first of all, what's the distance from here to here? That's 4 inches. And then how much extra is it going to be? Plus what? 2x. So this whole side is 4 plus 2x, okay? Because I've got, here's the width of the photograph is 4. I've got x and x, okay? So that tells me From the top of the frame to the bottom of the frame is 4 plus 2x. Now let's look at total from left to right over here. So if I'm going from here all the way to here on that frame, that's going to be what? 6 plus what? 6 plus 2x, okay? So you see now that is an algebraic representation of the entire photograph plus the frame. Now I know that the area of this whole thing is equal to what? Yeah, the 63 inches, okay? So that's going to be my expression. So I'm going to know that the area, so the area of the photo plus the frame is equal to 24 plus 39. Okay, the area of the photo plus the frame is 24 plus 39. Yes, Jack? They told me that the frame or the mat, whatever it is that goes around this photograph, is uniform width. So I don't know how wide it is. Okay, so I mean, it means the distance from here to here is x, here to here, here to here, and here to here. If the photograph, remember this photograph is 6 by 4, okay? That means that the entire photograph plus frame is 6 plus x, and then 4 plus x plus x. So 6 plus 2x, 4 plus 2x, okay? So that's really the key in all of these problems, is getting that diagram, setting this up correctly. So the area of the photo plus the frame is 24 plus 39. So that means that 6 plus 2x times 4 plus 2x is equal to, and you'll see why I'm in it, I just write this 24 plus 39 instead of adding that together. Now, do you see how this is a quadratic model now? Yeah, because I've got, when I multiply these two terms together, I will get a quadratic equation. So let's do that. 6 times 4 is what? Yeah, so I get 24 plus 12x plus 8x plus 4x squared equals 24 plus 39. Okay, so all I did was FOIL the binomial. So 24 plus 12x plus 8x plus 4x squared equal 24 plus 39. Now I can make it a little bit easier. What about this 24 on both sides? Yeah, I mean, I can, if I subtract 24 from both sides, that goes away, okay? This becomes 4x squared plus how many x's? How about 20x equal 39? So I can write this as 4x squared plus 20x minus 39 equals 0. How do I solve that? Easiest way is with your TI Nspire. So if I go over here and say menu, algebra, polynomial, complex roots, 4x squared plus 20x minus 39 comma x. So solve 4x squared plus 20x minus 39 equals 0. Solve that for x and you get two numbers, negative 13 halves and 3 halves. Now what does x represent? The width of the frame. Which of these makes sense? Right. It doesn't make sense to have the width of a frame being negative 13 halves. It makes sense for the width of that frame to be 3 halves, okay? So according to this, x is going to be 3 halves. Now go back to our original, what did they ask us to find? How wide is the frame? So the frame is how wide? It's 3 halves or 1.5 inches wide. So the frame is 3 halves or 1.5 inches wide. Now, another question I could have asked you are, what are the dimensions of the frame? How do I find that? If I ask you what the dimensions of the frame are, how would you find that? Yeah, so this frame would be, what's 2 times 1.5? 3. So the frame is going to be 9 by what? 9 by 7. This frame will be 9 by 7. Okay, so that's another kind of question I could have gone back and said, what are the dimensions of the frame in order to make this problem work? Okay, easy, hard, what is this one? What's the hardest part of this? Okay, well, that part you can control. Yes, Jack. Pardon me? Well, we're dealing here with two-dimensional, okay? But I mean, if you've got something like a rectangle, you got width and length. Width is the shorter of those. Okay, so since this is a 4 by 6 photograph, we would say it's 4 wide and 6 long. Okay, but there's no you could have called it the other way around. We just traditionally use width when I've got two dimensions, width for the shorter of the two. Okay, so in this case, I will say that this is a 4 inches wide, 6 inches long. Well, in this case, this happens to be length. Did I say width up here? So in this case, this is the length, okay, is the width, okay? So if I look at the frame, so the final dimensions, of the frame is going to be 6 plus 2 times 3 halves and 4 plus 2 times 3 halves. So this is that's my length, and that's my width. So this is a 9 by 7, a 9 by 7 frame. 1.5 is the width of the frame. Okay, so I got two things going on here. So I'm saying, so the picture is a 6 by 4. That is the length of the photograph. That's the width of the photograph. And then when I have a frame, 1.5, that's the width of the frame. So there's a width of a mat or frame going all the way around this picture. Okay? So again, the trick in setting these up is that 2x thing, okay? The dimensions, if x is the dimension of the width, then your outer dimensions of your object are going to have something involving 2x. Let's look at another example. This one is near and dear to my heart. How many of you have this poster in your room? What does this mean? I love algebra. See, isn't that nice? This is sort of a final exam review. So I did change this up last year before your book was published. This was my senior photo, my yearbook photo. So hopefully you'll like this one better. So in decorating your bedroom, you decide to frame your favorite math poster. The poster is 11 by 14, and the frame that you use has an area of 150 square inches. What is the width of this frame? And all of these, we're assuming the frame is uniform width, okay? So what is my variable here? Let x equal what? X is going to be equal to the what? The width of the frame, okay? So the width of the frame. So that means that the distance from here to here is x, the distance from here to here. So all around this frame, I've got something of width x, okay? Now, if I look at it, what is the distance from, say, from here to here is what distance along just the picture? That's what? That's 11, okay? The distance from here to here along this is what? 14, okay? So the total area, so this is going to be X up here, and that's X. So what is the total length of that whole side is what? 11 plus 2X. This whole side here is what? 14 plus 2X. Now, what do I know? The area of the frame is what? 150. The area of the photograph is what? How do I get that? It's 11 times 14, right? Yeah, so I know that in this, my model is going to be 11 plus 2X times 14 plus 2X is equal to 11 times 14 plus 150. Okay, so the total area of the frame is the area of the poster plus the area that width of the frame has. Okay, so 11 by 14, somebody said that number is what? 154? Okay, now let's FOIL this. 11 times 14, that's 154, plus 2x times 11x, that's 22x, plus 2 times 14, that's 28x, plus 4x squared. The 154 on both sides, what can I do with that? When I subtract 154 from both sides, that's going to cancel for me. So on the left, I'm going to have 4x squared plus what? Plus what? 50x equal 150. So 4x squared plus 50x minus 150 equals what? 0. And what do I do with that? Anybody want to do quadratic formula? Yes? No? Okay. Let's go back and use our favorite command here. So I can just recall that command. So I'm going to have 4x squared plus, what was it, 50? 50x and then minus what? X is equal to negative 15 or 5 halves, right? So X represents what in this problem? The width of the frame. Which of those makes sense? 5 halves. It doesn't make sense for the width of the frame to be negative 15 inches. Okay, so the width is going to be 5 halves. So here I know that X equal 5 halves. So that means that the width is what, 2.5 inches. Okay, how are these? Are they comparable to projectile motion? Easier, not easier, what? Okay, it's all right. Yeah, so I mean, it's just the trick of that 2x that gets thrown in there in the dimensions. Now let's throw a little bit of a wrinkle in it in the next problem. The outer dimensions of a picture frame are 20 by 12. The area of the picture that is exposed is 84 centimeters. What's the width of the frame? Now, how is this problem different? Pardon me? It's centimeters. That's one difference. There's another difference. Let's draw it out first. So the outer dimensions are 20 by 12. So I've got something that this is 20 and this is 12. That's the outer dimension of my frame. Now the picture is inside of here, right? So the picture, there's a picture inside of here. And what do I know? Do I know the size of the picture? No. What do I know about the picture? All I know is its area. So I know that the area is what? 84 centimeters squared. Okay. Now, we'll do the same thing we did. Let x equal what? Is the width. Let x equal the width of the frame. Now, how do you think? What do we think I deal with this? What's different at this point? Yeah, so before I would write the area from here to here is 12 plus 2x. That's not true here. What's the distance from here to here? Just a moment, okay? This is 12, that's 20. Question, Jack. Well, in the previous one, I had a 4x6 picture, and I put a frame around it, but I didn't know how wide the frame was. That means the thing you know is the picture. You don't know the dimensions of the frame. Here, this is reverse. I told you the dimensions of the outside of a frame are 20 by 12. So I know the dimensions of the frame. I don't know the dimensions of the picture, okay? So what I don't know in this equation, so if you look at it in the previous two, like I knew that this poster was 11 by 14. I didn't know how big the frame was because I didn't know how wide the width of the mat or the frame was. In this one, I knew the picture was 4 by 6, but I didn't know what the outside of the frame would be. Here, it's just a little bit different. Come on. In this particular case, what's different is I know the outside dimensions of the frame, but I don't know what? The dimensions of the photograph or art or whatever it is. So I need, pardon me, yes? Just because I drew it that way. I mean, you could draw it, the other way around. You could say, we could draw it this way and say that that's 20 and this is 12. Problem will still work the same. So I've got something like this. Doesn't matter. That part doesn't matter. Okay. So the problem is going to work the same. I mean, think about it. If you've got a picture, you can hang a picture on the wall this way, or you can hang it this way. It doesn't change the area. Okay. So it doesn't matter which way you wrote that. Now, what's the equation that I set up? What is it that I don't know? I don't know the area of the picture. I know the area of the frame. The area of the frame is what? 12 times 20. That's 240. So I need an expression. What I don't know is the area of the photo. So I need an expression for the area of the photo. Okay? Now, I know that the distance from here to here is 12. Okay? The distance from here to here is what? Yeah. The distance from here to here is what? So what do you think the distance from here to here is? 12 minus 2x. Okay? So if this is 12, so if I break this down, that has to be x, and that has to be x. So the distance from here to here, that distance has to be 12 minus 2x. And then we do the same thing over on this side. The distance from here to here is x. The distance from here to here is x. The total distance was 20, so this distance in here has to be what? 20 minus 2x, okay? So that's the trick on this one. If I give you the outer dimensions and you're solving for the inner dimensions, you're going to have a minus 2x somewhere in that equation. If I start with the inside dimensions and ask you for the outer, you're going to have a plus 2x. So the model for this is going to be, what's my expression in terms of x for the area of the photo? What is it? 12 minus 2x times what? 20 minus 2x equals what? 84. Okay. I know the area of that photograph is 84. So 20 minus 2x times 12 minus 2x equal 84. What do I do now? All right, just multiply this out. So I can have 12 times 20, that's going to be what, 240. And then I get what, plus 4x. Wait. So I'm going to get what? Come on, one more. 240. And it's going to be what? Minus 40x and minus 24x plus 4x squared equal 84. Because in this case, I know the area of the entire frame is 240, but what I'm solving for is the area of the inside picture. So this 12 minus 2x and 20 minus 2x, that's the distance from here to here and here to here. So when I multiply those together, I get the area of the inside photograph, and that's 84, okay? So this one's a little bit backwards. The other ones, you started with the photograph, you had to add the area of the photograph to the frame to get the area that the whole frame takes up. Here, you know the area the whole frame takes up, and you just got to figure out the area of the inside photograph. So let's see, this is what, 4x squared minus 64x plus 240 equal 84. So 4x squared minus 64x. What's 240 minus 84? So 240 minus 84 is 156. So plus 156 equals 0. And then what do I do with that? Yeah, calculator. So menu, algebra, polynomials. So 4x squared plus 64, was it plus or minus? Yeah. Minus 64x plus, what was it, 156? Solve that for x. 3 and 13. Okay, so my answers are 3 and 13. Let me go back. So here I get x equal 3 and 13. Now, which of those makes sense and one of those does not make sense? So x stands for what? The width, okay? What if the width were 13? That means this side would be 12 minus 2 times 13. What's 2 times 13? 26. 12 minus 26. Can the frame be 12 minus 26? No, it cannot be. I get negative dimensions for the frame, so it can only be 3. So x equals 3, so this frame is 3 inches wide. If I were to ask you for the dimensions of the photograph, how do you find the dimensions of the photograph? You plug in x, so this photograph is going to be 12 minus 6 and 20 minus 6. So this photograph is going to be a 6 by 14 photograph. So there were 2 variations of this problem. If I give you the inside dimensions of a photograph or piece of art, x is always going to be the width of the mat or the frame. So in that case, the problem sets up with a plus 2x, and your expression is for the entire dimensions. If I give you the entire dimensions and you're solving for the inside photograph, you're going to have a minus 2x in your problem, your formula, and you're solving for the dimensions of that inside photograph. Okay? Any questions over this? Okay, what I want you to do, take a look at this if you need to. Take a look at the homework. Let's go ahead and, the biggest thing is setting them up. See if you can read the homework, get the setup, okay? I think once you get to the equation, this part pretty straightforward, right? I mean, once you get to here, it's getting this diagram and getting this setup. So take a look at those. Let me know if you have questions, okay?